Hello, this is Brian with BG3D. Today I've got to make a guard. Now, a guard is usually the very last thing I do. I try to make them simple. If you look real close, you'll see there's a few things on here that aren't quite finished. I won't actually fix these bushings or do anything like that until the parts are actually ordered because obviously we have supply chain issues at the moment. First thing I'm going to do is actually do some measuring though. I need to see. So that's 2 1/4. The shaft itself is 2 1/8, but there's a key. So 2 1/4. And that one is 2 3/16 diameter. We go sketch. The standard. Start sketch. And I'm going to do that on the XZ. We'll start at the top. 2 1/2. Down here, we're going to go 3. This top circle is going to represent the upper shaft, the hole for it. These are the easy ones to measure. 7.1. So this will have belts. You got to leave enough room for them, for the belts to be able to get them on. So we'll go 9 inch. And that one is 10. So we are probably going to go with a 12. Draw a couple more circles, just make them equal. Okay, so what those represent is this shaft and this sheave. The thing you got to pay attention to with it is it moves. So that's why there's 2 of them. It's actually going to be a slot. So what I want to measure now is from the center line of this to the center line of the gearbox. These are the 2 center lines. I'm just going to copy that. So I'm going to go back in here and I'm going to draw another circle. Use Control V times 2, which gives me that diameter. Okay, so these are going to rotate around that shaft. The thing I don't have at the moment is I don't have a way of holding this in place. So if you notice, you just take it and drag it. So the next thing I'm going to do is lock it in place. And I just draw a line, and it's just for construction. This is for construction also. So I have to pick something on here that does not move. We're going to use the front of this piece of plate. 7.5 inches. I'll drag it down because it's actually below. It's 8 inches below. Okay, so if you look at it, Next thing we're going to do is locate this shaft. Kind of an optical illusion. So let's see if it's a 1/4 inch below it or above it. 0 degrees on the plane. The reason I make a plane just makes it real easy and real clear to see. And the center line of that shaft is a 1/4 inch above. And at that point you can do this. Measure from the axis up, and then you can really tell it's a 1/4 inch above. So we're dimension it from here to there, 0.25. The next dimension we have to get will be from this point do not need the plane anymore. So get rid of it from that face. It's 12 inches. So I'll get that to 12. So what we have so far is this shaft located, this shaft. We have the centers from here to there. So the next thing we're going to measure is get 25.491. I don't even try to remember these anymore. There's several ways I could do it. So the dimension I got was from here to there. Then when it rotates over, the second circle I would draw would be from here to here. I could use this same point, but then I have to get more dimensions. So circle, it's for construction. Times 2. Go back, rotate it forward from axis to axis. 27.7359. So we'll do a circle. Shoot Control V times 2. Okay, so this circle's already snapped on the first one. Now we're going to snap it to the second one. So that's your two centers. This line is construction. Now we can start actually drawing on the guard. This is all the construction work to get to that point. And I'm just going to draw some lines that are sort of random, but sort of not. All makes sense here in a minute. The thing that you're going to notice is right now this and this are just equal. When I actually start trimming on these, they're going to lose their constraints. They'll keep them, but they'll lose them. They won't be purple anymore. They won't be fully constrained. All these construction lines, sometimes this can be you'll think you have everything, and then you start trimming, and something is not there. It'll snap to whatever line it comes to first. So You always kind of have to look at it a bunch of times to see if it's actually going to what you want it to. Just like this, it's not going to the circle, it's going to the construction line. That won't be straight. That was a mistake. It'll be another piece of an arc. I don't know if it'll let me do this. Nope, it will not. Alright, time for some trimming. Ooh, that was a mistake. So you'll notice now they're not fully constrained any longer. But we're going to have a lot of those problems with this. Not a big deal. Just have to make constraints. That is all. Let's go back to being construction. Now let's see what it takes to get everything constrained. We got those. Alright, so we have the outline of our guard. Notice there's a whole lot of construction going here for just a little bit of work. So finished sketch, 3D model. I'm going to extrude this 0.196. That is the thickness of 11 gauge. That would be our back plate. Three. Back plate. So we're going to place our black back plate just in an assembly. Constrain, I'm going to use the planes. It's not the direction I want it to go. I need on XZ. And like so. Change that. Because I know that's where the axis was. And I know this is where the other axis is. So this is just the beginning of an assembly. It's a guard I've done earlier. Find in the browser, there are some parts of this guard that I need. So this, I'm not going to open it, I'm just going to copy some parts. This is a tap block. I think it's about a $3 item from MasterCard. The option to this is to either you purchase something like this block, you take a piece of angle and weld a nut to it, or you have someone drill and tap them. But I found in the past that for $3 it's kind of hard to get anything made for $3. I happen to know these are square, so I'm not going to focus on the sides of them. Where I'm snapping to, just going to make them flush. Okay, the rest of the constraints. These are basically the ends of flats. So what I'm doing at the moment is, this will be your back plate for your guard. And I just use drill and tap blocks. And then there's going to be a cover that goes over it. It'll have a piece expanded, it'll be cut out. It'll make the rest of the guard. And it's just going to be 03 back plate. Okay, so let's place it and see if I turned it the right way. I'll figure out exactly where it goes later. So on this back plate, the thing I need to know for me to constrain it right is right here. And I'm going to accept that as 9.074. Make that a negative. So now when you move this, it should just follow that arc, which it does. The next step is actually pretty simple. Once you get this shape figured out, the rest of the parts are very easy. I'm going to copy the sketch. I'm going to go New, Standard. start 2D. I need to be on the XZ again. So you can paste it and reconstrain. Now, this will give you your outline of your outer plate. This time I'm going to extrude everything. I'm not going to leave the holes in it. And this is where I'm going to start. I'm going to make it yellow. I'm going to save it. 3. Front 3. I'm going to copy the sketch again. This time we're going to go sheet metal. Yes, I know I need to synchronize it. So start 2D sketch. XZ. Paste. Okay, so here's the only trick to this. Right now, if you hit contour flange and you pick that, it will not do it. It's a continuous loop around it. So what you do is you go edit, and you gotta think about the way the break works. Well, we got a break in instead of rolls. We can actually roll this shape, and roll this, and roll this. Now there has to be, it's a tangent that comes off the break to actually make the shape. So what I usually do is go here and find me a place. I see something that should have been trimmed. I'm looking for the end of this line. And I'm just going to draw a couple lines and make them perpendicular. And we're going to give them a couple constraints. We're going to make them construction lines. Make those two equal. We'll trim. You notice everything stays fully constrained. We have finished sketch, contour flange. Dimension is 6 inches. Need to flip that to the outside. Sheet metal defaults. The outside of this will be 14 gauge. Plate. Yellow. Okay, new. Make a new assembly. I'll place the front. Okay, so we got mate. Sometimes these become a little bit uncooperative. So right now it will still rotate around that point. Let's try doing that a little different. Seems I got the same issue on the other one. Okay, now it's constrained. Save it. 3. We got an equal opportunity here to put this together the right way and have it backwards. So we shall see. And if I do it backwards, well, we just reconstrain. It's not the end of the world. So if you like my videos, find this to be useful or helpful, don't forget to like and subscribe. And if there's something else you would like to see or to know how I do it, all you gotta do is ask the questions. Close a few things and we shall place the guard on here and see if we've done it backwards or the right way. Okay, we have a guard, everything matches, mates up. We put holes in the top and bottom for the bolts. Something I'm going to do to it first though. Start a sketch. Check geometry. The thing about a guard is you kind of need to be able to see inside it so you can check a belt without taking it apart. This one is a construction line. I'm actually going to cut this out after I add a couple of dimensions to it. 25, and I think this one's 21. Okay, so what I've done. Okay, so now that the window is cut in, All I gotta do is put a piece of expanded metal behind it. And I just happen to have a piece already made. I have other guards that's using the same piece of expanded. I mean, I could get all fancy with it. It made it round, it made it fit a little better. But at the end of the day, they're using it as a window to look inside there to see if the belts are on or what condition they're in. So like I said, just got to put holes in the top and bottom. I mean, here's why I use the sheet metal, the editor on it. Because it gives me my flat pattern. I don't have to sit there and figure it out for the shop. I mean, this along with dimensions, and they can very easily make the part. Because at the end of the day, they're going to make that part fit this shape. I'm going to dimension it accordingly to what it actually is, but they're still going to make it to fix this shape. Thank you very much for watching my video. Leave me some feedback.